Day 299 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 59, spiral matrix 2. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Question says, given a positive integer n, generate an n by n matrix filled with elements from 1 to n squared in spiral order. So it sounds simple enough, y'all, but let's go ahead and take a look at these examples so we can make sure that we're doing exactly what it is that they want us to do, right? So in example 1, we have the input n equals 3. Now remember, we're given an integer n and we need to generate an n by n matrix, which means we need to generate a 3 by 3 matrix with elements from 1 to n squared, right? So 3 squared would be 9. So we need elements from 1 to 9 in a 3 by 3 matrix, right? N by n matrix from 1 to n squared, right? So that's where we get the elements from and the numbers from. That's n squared. 9 is n squared. So that means we have to make elements from 1 through 9. And the grid should match with that perfectly because the grid should be n squared, which is a 3. I mean, not n squared. The grid should be n by n, which is 3 by 3. So the output says it returns a 2D array of integers, with the first array being 1, 2, 3, the second one being 8, 9, 4, and the last one being 7, 6, 5. So as you can see, each one of these arrays inside the initial array, so like this array right here, this represents the first row, boom. Then this represents the second row, boom. And finally this right here represents the third row, boom. So that's how we got that output from this input, right? So let's go ahead and look at example 2, where it might be, they might throw a little trick our way where n equals 1 this time. So in example 2, n equals 1, the output is 1 because a 1 by 1 grid would mean it's only one cell, and 1 squared is 1. So that's why the output is 1. So now that we understand the question, y'all, let's get into the fun part, actual solution. Solution is not that difficult, so I'm hoping y'all will be able to understand it fairly well. So, y'all, let's get into it. Now, the first thing we need to do is we need to create our n by n matrix. So in order to do that, we could just say let map equals, it's going to be an array of integers. So we can say open up the square brackets, say put int inside of the square brackets, open up the parentheses. We're going to initialize it with repeating colon -1. So to start, the values are just going to be -1, but those will change as we write more code, and our code change those will change as we go along, but this is just our default value. Then we're going to say comma count colon n, boom. Then we're going to come right here, we're going to declare a variable called res, and we'll set that equal to an array or a 2D array of integers, because remember our output is a 2D array, which is an array of arrays. So that's why we create a 2D array like this. This is an array of arrays of integers, an array of arrays of integers, right? So that's how we write that, and that's how the output is. As you can see right here, it's an array of integers. Then we're going to come out here, right here, we're going to initialize that with repeating colon, then we're just going to say map comma count colon n, just like that. Now we need the total number of elements in the matrix. So to do that, we could just come right here and we can say let grid equals, open up the parentheses, n times n, just like that. Now we need to define the boundaries for the spiral traversal. So in order to do that, we could just come right here. We could declare a variable. We could call it top, set that equal to 0. Then we could say comma btm, short for bottom. We could set that equal to n minus 1. Then we could say comma LHS, set that equal to 0. Then we could say comma RHS, set that equal to, open up the parentheses, n minus 1, just like that. Now we need a counter to track the current number being placed in the matrix. So in order to do that, we could just declare a variable, and we could call it cur, and we could just set that equal to 1 just to start as a default value. Now we need to continue filling the matrix until we've placed all of the numbers. So in order to do that, we could just use a while loop, and we can say while cur is less than or equal to grid. We can open up the brackets, and now we need to traverse from left to right along the top row. So in order to do that, inside our while loop, we could say if LHS is less than or equal to RHS and two and signs, cur is less than or equal to grid, then we're going to open up the brackets. We're going to say for I in LHS dot 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 RHS. I'm going to open up the brackets again, and we're going to say res square bracket top, come outside of that square bracket, say square bracket I. Then we're going to say is equals cur. Then we're going to increment cur by 1, so we're going to say cur plus equals 1. Then we need to move the top boundary down, so we're going to come underneath this for loop, and we're going to say top plus equals 1, just like that. Now we're going to come outside of this if statement, and we're going to start another if statement, and this is going to traverse from top to bottom along the rightmost column. So in order to do that, we're going to say if top is less than or equal to BTM and two and signs cur is less than or equal to grid, then we're going to open up the brackets, and we're going to say for I in top dot 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 BTM. We're going to open up the brackets. We're going to say res square bracket I, come outside that square bracket, and we're going to say square bracket RHS, and we're going to set that equal to cur. Then we're going to come underneath that. We're going to say cur plus equals 1. Then we need to move the right boundary left. So we're going to come outside of this for loop, still in the if, and we're going to say RHS minus equals 1, just like that. Excuse me. Now we need to traverse from the right to the left along the bottom row. So we're going to come outside, once again, come outside this if statement. We're going to start another one. We're going to say if LHS is less than or equal to RHS and two and signs, cur is less than or equal to grid. Then we're going to open up the brackets. We're going to say for I in, open up the parentheses. We're going to say LHS dot 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 RHS. Clean this up, my bad, y'all. RHS. Then we're going to come over here outside of those parentheses, and we're going to say dot reversed. Then we're going to say parentheses. Then we're going to open up the brackets, and we are going to say res square bracket BTM. Come outside those square brackets. We're going to say square bracket I. We're going to set that equal to cur. Come underneath that, we're going to say cur plus equals 1. And now we need to move the bottom boundary up. So in order to do that, we're going to come right here. We're going to say BTM. It's going to be BTM minus equals 1, just like that. And now we need to come outside this. We're almost done, not done yet. We still need to traverse from the bottom to the top along the left side or the leftmost column. So in order to do that, we're going to say if top is less than or equal to BTM and two and signs cur is less than or equal to grid. Then we're going to open up the brackets, and we're going to say for I and open up the parentheses top dot 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 BTM dot, come outside those parentheses, and we're going to say dot reversed, then parentheses. We're going to open up the brackets, and we're going to say res square bracket I, come outside that square bracket LHS, set that equal to cur. Then we're going to come right here, cur plus equals 1. then we need to move the left boundary right. So this time we're going to come right here and we're going to say LHS plus equals 1, just like that. Now, last but not least, we need to return the filled spiral matrix. So in order to do that, we could just come right here and we could say return res, just like that, y'all. So that should be all she wrote. Let's go ahead and run it. Make sure it runs properly. Let's see. Okay. So we got an error. Let's see. Where's that error? It's probably. Let me see. Here. Oh, sorry. This shouldn't be a colon. That should be an equal sign. Sorry about that, y'all. Let's run it again. See if it works this time. And it's accepted, so let's go ahead and submit it. Make sure it stays accepted after we submit it, y'all. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I like to see. Those are some good numbers right there. Now, before we leave, make sure y'all get one more look at the code. Make sure y'all learn it, read it, love it, and understand what's going on here, y'all, because there's no point in writing code that you don't understand, because then you definitely didn't learn anything if you don't understand it. So this is the middle part of the code. Get one more look at that. Get one more look at that. Then let's check the last part. This is the bottom part of the code right here. Read it, learn it, love it. Make sure y'all get all of that good code right there. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.